Welcome back to our Science Online Learning. This is still your Teacher Heidi. Our subject is Basic Science, SEP in Mathayum 2, with the code of SC22102. How are you feeling today? I hope everyone is doing well. Our lesson for today is all about energy. So for today's lesson, we are going to have the following objectives. First, show understanding of the physics concept of kinetic energy. Recall and show understanding of the formula. Distinguish situations involving kinetic energy and solve related problems involving kinetic energy. Now, when we say energy, what does it mean? So, energy here is what we call the ability to do work. Energy is the ability to do work. An object that stores more energy has the ability to do more work than the other object that stores less energy. So energy is a scalar quantity and the SI unit for energy is joule. So I repeat, energy is the ability to do work. Energy cannot be created or destroyed, but it can be transferred from one object to another and converted into many forms. Example, solar cells convert solar energy into electrical energy for household use, and the human body converts the chemical energy in food into mechanical energy for muscle movement. So I repeat, energy is the capacity or ability to do work, and the unit for energy is joule. And it composes of many forms. So you can see here the different forms of energy, and they fall under two categories or types. We have here the potential and kinetic. When we say potential, these are the forms of potential energy, stored energy, or a energy of position. So we have chemical energy, nuclear energy, stored mechanical energy, and gravitational energy. Now under kinetic, we have the following: radiant energy, thermal energy, motion energy, sound, and electrical energy. Now kinetic energy here is energy in motion. It is the motion of waves, electrons, atoms, molecules, and substances. Whereas when we say potential, it's a stored energy and the energy of position. Clear? So when work is done, the energy transferred is called mechanical energy. Mechanical energy is the energy stored in an object due to its motion or position. For example, living organisms convert chemical energy stored in food into mechanical energy to do work such as walking and lifting weights. So do you know the types of mechanical energy? Due to its motion or position. Very good. We have the two types. We have the kinetic energy and the potential energy. So let us first discuss them. So the first one is what we call kinetic energy. This is the energy stored in an object due to its motion. So the kinetic energy depends on two things. We have mass and speed. And the kinetic energy of an object increases when its mass or its speed also increases. So if two objects in motion have the same mass, the one that moves faster has more kinetic energy. And if two objects are moving at the same speed, the heavier one has more kinetic energy. Clear? Very good. So these are some examples of kinetic energy. And it depends on two things. We have the mass, the velocity or the speed of an object. And in order for us to get kinetic energy, this is the formula that we're going to use. Ke equals 1/2 times m times v squared. M is the mass and v is the velocity or the speed. And the unit is in joule. Okay? So here are some problems that you're going to work on in kinetic energy. For the first one, we will get 2,000 joules. Second one, since the mass is increased, the kinetic energy would also increase. And the third one, if it is unloaded, meaning it has nothing in it, it will move faster. Okay? Did you understand? So if the mass doubles in kinetic energy, its kinetic energy will also double. And if the speed or velocity doubles, its kinetic energy will also increase 4 times. Did you understand? Now here are some other examples that you can study at home. Okay, so that's it for kinetic energy. Do you have any questions? Now let us move to the next, which is the gravitational potential energy. I'd like you to understand the physics concept of gravitational potential energy, or the GPE. Recall and understand the formula, distinguish equations about GPE, and solve related problems about the GPE. So the second type of mechanical energy is what we call the potential energy, or it's represented by EP or PE. It is the energy stored in an object due to its position relative to other objects or its state. Like for example, a rock on top of a hill, a book held over your head, and a stretched spring, all of them have potential energy. And there are two forms of potential energy below. So first, let us have the gravitational potential energy, or the GPE. The GPE is the energy stored in an object due to its vertical position or height. This energy is stored in an object due to the pull of gravity on the object. The gravitational potential energy of object depends on its mass and height above the ground. The heavier the object is, the higher it is above the ground, the greater its gravitational potential energy. For example, a rock on a cliff has more gravitational potential energy than a rock on the ground. The gravitational potential energy of a rock decreases as it falls from the cliff. Okay? Now, the second type of potential energy is what we call the elastic potential energy. This is the energy stored in an elastic object due to being deformed, stretched, or compressed. This is the energy that makes a deformed elastic object return to its original shape. For example, when we turn the arbor of a mechanical clock, its spring winds up and stores energy, which is used to run the clock as the spring unwinds. The elastic potential energy stored in an elastic object depends on the distance it is deformed and its spring constant. Now, the spring constant is the force needed to deform a spring, divided by the distance that the spring is deformed. Elastic potential energy increases with an increase in spring constant and with an increase in the deformed distance. So I repeat, potential energy is the energy stored as a result of its position or condition. And there are two kinds. We have the GPE and the elastic potential energy. So in elastic potential energy, this is the energy possessed by an object due to its condition. Examples: slinky when stretched or compressed, spring when stretched or compressed, rubber band when stretched, and balloon with air when compressed. So here are some examples of elastic potential energy. You understand? And this is also how we get elastic potential energy. Okay. Now let us move on to the GPE, or the gravitational potential energy. So energy that can be possessed by an object due to its position is what we call the GPE, or the gravitational potential energy. In physics, ground level is normally assumed to be at 0 GPE. So when you are on the ground, the GPE is 0. Any object that is at ground level has 0 GPE. If an object is lifted at a certain height above the ground, the GPE has also increased. So these are some examples of gravitational potential energy. When a chair is lifted from the ground at a distance of 1 meter, and you are sitting on the 4th story of this building. So, in order for us to calculate GPE, we need to get the three important things. M is the mass, G is the gravitational acceleration, and H is the height. So the G here is always constant, which is 10 meters per second squared. And if you could already get those three, then you can already get the GPE of an object. And of course, the units are below. And the standard unit for GPE is always in joule. Understand? Okay. So let's analyze some problems here. You lifted your bags to the top of your table. What can you say about the GPE of your bag? Is it 0, increase, or decrease? Very good. It increases. Now you lift the same bag on the moon. What happens to the GPE? It still increases. And will the GPE be the same on moon and earth? Less on moon. Very good. Did you understand? So here are some situations in order for you to get the GPE of the object. So the work done when you lift the book is also the same as the GPE gained by the books when you lift it at a certain height. Okay, can you do this one? Okay, let's see the answer. What is your answer? Very good. It's 200,000 joules or 200 kilojoules. What about the second one? What is the answer? it's 20 meters. Take note, you are looking for height here. And this is the formula. And the third one. Very good. Now this time we're looking for mass, and this is how we get the mass. Do you have any question? Very good. So when an object is above the ground, it stores gravitational potential energy. This gravitational potential energy will be converted into kinetic energy as the object falls toward the ground. For example, when an object M is dropped from a height, its stored energy is converted from one form to another as shown in this picture. Okay. So after dealing with the two types of energy, let us now move to the last part of the lesson, which is all about the conservation and conversion of energy. I'd like you to take note of the following objectives. Understand conservation and conversion of energy. Correctly distinguish situation involving energy conservation and conversion, and solve related problems. Now, can energy be created or destroyed? Energy cannot be created nor destroyed, but it can only be formed from one form to another. So, in the law of conservation of energy, it states that energy cannot be created nor destroyed, but it can be changed from one form to another. So the total amount of energy before is the same as the total amount of energy after. Now that is what we call law of conservation of energy. E1 is equal to E2. E1 represents the initial stored energy in the object, while E2 represents the final energy stored in the object. So these things happen all of the time. So the term that we can denote to change energy from one to another is what we call transformation of energy. And here are some examples. Did you understand? Very good. Okay. So the same is true in free-falling bodies. So an object in free fall means the object is freely falling under the influence of gravity. So when the object is at its highest position, this is the highest position, the GPE is at maximum and the kinetic energy is 0. And when the object starts falling down, the GPE is also decreasing. It loses height and the kinetic energy increases. Did you understand? And at the lowest point, which is here, the kinetic energy is at maximum while the GPE is already 0. So you can take a closer look on this picture. Now you can see that this is a girl falling down on a hill, icy hill. And you can see that at a certain distance, you can also take note of the amount of energy in all the areas where she went. Okay, and you could also see here the distance. Now look at what happened. The energy there was maintained. Okay, so the total energy in all the areas there is the same. It's 50,000 joules. Is that clear? So when you add the two, you will get the total mechanical energy, which is Ke plus PE. And it will be 50,000 joules. So energy is conserved. And the same is true with this picture, a pendulum. So don't forget, the law of conservation of energy states that energy cannot be created or destroyed, but it can be transformed from one form to another. And it's represented by this formula. Now, in the next slide, you could see here the different transformation of energy in some of the activities that happen in our day-to-day life. So first is what we call the hydroelectric dam. The stored gravitational potential energy in the water behind the dam is converted to kinetic energy. The second one is green plants. When green plants make their own food during the process of photosynthesis, they convert the light energy from the sun into chemical energy. The third one is what we call the chemical energy is stored in our fuels, are converted into thermal energy or heat when we burn them. The electrical appliances used for heating, such as electric irons, toasters, and hair dryers, have a nichrome wire as their heating element, which converts electrical energy into thermal energy in the form of heat. And finally, the chemical energy stored in fluorescent materials can be released in the form of light. For examples, fireflies use chemical reactions in their bodies to make light. And the last things are what we call the applications of energy in our day-to-day activities. So first is in generating electricity. Second is construction. Third is in air transportation. Fourth, in community water system. And fifth, in retractable pens. Did you understand all our lessons today, girls? Very good. For the activity time, I'd like you to open the PDF file and do the activity indicated about energy. Now, I'd like you to print this worksheet and send this when you come back to school. Good luck, girls! After the lesson, click the link in MS Forms and answer the quiz. This will be recorded. So that's all for today. See you in our next period. Goodbye!